Hello, this is Mr. Miller. Welcome to video 3J on higher order derivatives. We're going to take not only first derivatives, but second derivatives, maybe even third derivatives. We're going to work through several examples from the book. So here we go. Here are the first examples. We're going to do the even problems here. So the first function is f of x equals x plus 32x to the minus 2. And our directions are to find the second derivative of the function. Well, in order to find the second derivative, you have to find the first derivative first. So the first derivative would be the derivative of this, which is derivative of x is 1, plus. Then the derivative of the second term would be negative 2 times 32, that's negative 64, x to the minus 3. And I could simplify a little bit, that's 1 minus 64 x to the negative 3. Now, they gave us a problem with negative exponents, so I don't feel too bad about leaving it with negative exponents there. But we're not done. We have to take the second derivative, which means we take the derivative again. So we take f double prime of x is going to be the derivative of this. Well, the derivative of 1 is 0, and then we have minus 3 times a negative 64. That would be 192. X, and if we subtract 1 from the exponent, it would be x to the negative 4. That's the second derivative there. Okay, one down. All right, the next one we're going to do is 96. This is probably the most complicated one. 96, because it involves the quotient rule. And to be honest, after we take the derivative one time, it's still going to be a rational function. We're going to have to use the quotient rule again. So before we start, we might as well write the quotient rule up here. F over g prime equals g f prime minus f g prime, all divided by g squared. So that's a g prime there, believe it or not. All right, so let's do it. We have f of x equals x squared plus 2x minus 1, all divided by x. So in the quotient rule, the numerator is f and the denominator is g. So we get g times f prime minus f, which is this big mess, times g prime, which is 1, all divided by g squared, which would be x squared. Okay, well, that would be 2x squared plus 2x minus x squared minus 2x plus 1, all divided by x squared. And then after simplifying, we get that f prime of x equals, let me see, 2x squared minus x squared would be just x squared. 2x minus 2x is 0, so we have plus 1 over x squared. Okay, so that's the first derivative. It'd be nice to be done, but we're only half done. We have to take the derivative of that. Okay, well, we can do that. So again, using the quotient rule, f is the numerator, g is the denominator. Here we go. F double prime would be g times f prime minus f times g prime all over g squared. That'd be x squared squared. Okay, we got this. So this would be 2x cubed minus 2x cubed minus 2x over x to the fourth, which would be minus 2x over x to the fourth. We can cancel a factor of x, get minus 2 over x to the third. That's some math muscle. All right, so second derivative is negative 2 over x cubed. All right, the last one of these examples is one involving trig. So I copied the trig table here for our reference, and we want to take the second derivative of secant x. Well, the first derivative is pretty easy. It's in the table there. F prime of x is secant of x times tangent of x. I got that from here. Okay? So, the second derivative Well, we're going to need the product rule because this is the product of two functions. So to take the derivative again, we need this. F times g prime is f prime g plus f g prime, not double prime, prime. Okay, so when I take the derivative here, f prime, the derivative of secant, is secant x tangent x. That was f prime times g plus, I have to come down here, f, which was secant x, times g prime. The derivative of tangent is secant squared. Okay, I'll put some parentheses in so we can see kind of maybe the four parts. So f prime g plus f g prime. So now I just got to simplify a little bit. This is the product of three things. Tangent x times tangent x is tangent squared, so I can say secant x tangent squared x plus secant x times secant squared would be secant to the third x. There we go. So sometimes second derivative and third derivative can be kind of complicated because we may need the product rule or quotient rule. Okay, now let's try a little bit different problem. So we're going to do number 100. And it wants to know, wow, the third derivative. But they gave us the second derivative. So they gave us that f double prime of x is 2 minus 2 over x. To get the third derivative, we just take the derivative of this once. Because we're starting with the second derivative. One more would be the third. Okay, now, before we do this, let's rewrite this. This is equal to 2 minus 2x to the minus 1. Okay, so let's write this with a negative exponent. So f triple prime, well, the derivative of 2 is 0. And the derivative of this would be minus 1 times minus 2, which is 2. X to the minus 2, which is the same as 2 over x squared. We're done. That's the third derivative. Okay? We're going to do 102 now. So problem 102 says find the sixth derivative. But we're starting with the fourth derivative, so that's not too bad. So we're starting with the fourth. So instead of putting 4 prime marks, just put a little 4 there. In parentheses, that means the fourth derivative is 2x plus 1. So the fifth derivative would be the derivative of that, which is 2. And the sixth derivative would be the derivative of 2, which is 0. That was the easiest one all day. All right, we come to the two last examples. And this is kind of something that won't be hard, but it's kind of different than what we've done. We're going to do number 26. So number 26, we're giving two things. We're given a function here, and we're given what's called a differential equation. A differential equation is simply an equation with derivatives in it. So we're supposed to show that for this function that minus y triple prime minus x times y double prime minus 2 times y prime equals negative 24x squared. So what we have to do is find the derivatives and substitute into this and show that we get negative 24x squared. So I'll find the derivatives first. So y equals 2x cubed minus 6x plus 10. Fortunately, the derivatives are easy to find. Y prime is 6x squared minus 6. Y double prime would be 12x. And finally, y triple prime is just 12. So we're going to substitute into this equation. So minus y triple prime, so let me draw a line here, would be minus 12, because that's what y triple prime was, minus x times y double prime, 12x, minus 2 times y prime, 6x squared minus 6, is supposed to equal negative 24x squared. I'm going to put a little question mark. We want to show that it's equal to that. Okay, well, let's simplify. Negative 12 minus 12x squared minus another 12x squared plus 12. Well, if I cancel those, it does equal minus 24x squared. So it's true. Okay, so what happened? I put the derivatives into this left side, and we did get minus 24x squared. When I simplified all this, it became that, which equals negative 24x squared. All right, let's try another example of that. Let's try number 28, or 128 rather. So here's the equation or the function, and we want to show that the second derivative plus the original function equals 0. So the function was 3 cosine x plus sine of x. Y prime would be minus 3 sine of x, because the derivative of cosine x is minus the sine of x. And the derivative of sine of x is cosine x. That's the first derivative. Y double prime would be minus 3 cosine x minus sine of x. Now, let's go over here. We're supposed to show that y double prime plus y equals 0. So y double prime plus y would equal negative 3 cosine x minus sine of x. I just substituted what we have here. Plus y, okay, we're going to put in that. Okay, let's see what that equals. Well, minus 3 cosine x cancels with that. Minus sine x cancels with plus sine x. It does equal 0. So when I substitute this equation into this differential equation, it works. Y double prime plus y does equal 0. Okay, it's your turn. So find the second derivatives of these three functions. On the third one, you're going to need the quotient rule probably twice. Then, for number 2, show that y equals 4x squared minus 19x is a solution to this differential equation. So make sure that, just to be clear, this is the function right here. Make sure you include that last x. Okay, so that's the function, 4x squared minus 19x. So find its first derivative and plug the first derivative and the original function into this equation, and you should end up with 0. All right, see you next time.